So in this video, we're going to take a look at a number of different theorems that all come from section 7. The first theorem is called the vertical angles theorem. And the vertical angles theorem deals with vertical angles. So first, we should probably talk real quick about what vertical angles are. If I have two lines that intersect, like let's say I have these two lines here, then they create four different angles. We'll number them 1, 2, 3, and 4, right? We just created four different angles from those two intersecting lines. Now, the ones that are across from each other, like angle 1 and angle 3, or angle 2 and angle 4, those are going to be considered vertical angles. And the vertical angles theorem says that vertical angles are congruent. So in this picture here, we would be able to say that down here, angle 1 would be congruent to angle 3, and angle 2 would be congruent to angle 4. That's what the vertical angles theorem would say about this picture. So for this problem here, it says find the value of x and the measure of each labeled angle. We just need to recognize that these two angles here, these two angle measures, are vertical angles. So they should be congruent to each other, or that the 6x minus 45 should be equal to the 4x plus 5. So that would set up an equation that we can use our algebra skills to solve. First, I'm going to get all the x's to one side, so I'm going to subtract 4x from both sides. So that's going to say 2x minus 45 equals 5. Now I'm going to add 45 to each side, and that'll give me 2x equals 50. And then if I divide both sides by 2, I have x equals 25. So that's the first part of my answer, x equals 25. But then it says find the measure of each labeled angle. So now I have to take the 4x plus 5, and I have to substitute in the 25 for the value of x. So that's 4 times 25 plus 5. 4 times 25 is the 100. So now that angle is 105 degrees. Now, I don't actually have to do it again over here. I just used the vertical angles theorem, and I realize, hey, if this angle here is 105 degrees, then this angle over here will also be 105 degrees. So that's the vertical angles theorem. The next theorem is called the congruent supplements theorem. And this theorem says that if two angles are supplementary to congruent angles or to the same angle, then they are congruent. So in this picture here, if I told you that angles 1 and 2 add up to 180, and that angles 3 and 2 add up to 180, then what we would know is that angle 1 is congruent to angle 3. And it kind of makes sense, right? Because let's assume that angle 2 was, I don't know, let's say that's 150 degrees. I would estimate that to be about 150 degrees. Now, if I told you that 1 and 2 add up to 180, you would know that that would mean this is 30 degrees. But if you also knew that angle 3 and 2 added up to 180, it would mean that angle 3 would also be 30 degrees. And now you can see that angles 1 and 3 match. But that doesn't happen just because this is 150. No matter what angle measure I put for angle 2, this relationship would always happen where the angle 1 and the angle 3 would always end up being the same. So that's what the congruent supplements theorem tells us. Anytime two angles are both supplementary to the same angle, then they're going to have to be congruent to each other. Now, the next theorem is related to that one. It just changes the word supplementary into complementary. So if two angles are complementary to the same angle or two congruent angles, then those two angles will be congruent. So in this picture, if I told you that angles 1 and 2 add up to 90, and angles 3 and 2 add up to 90, you would be able to figure out that that meant that angle 1 and angle 3 have to be congruent. Just to walk through the same example we did last time, let's look at this and say that, oh, maybe this is a 50-degree angle. Well, if we know that angle 1 and 2 are going to be complementary, then angle 1 has to be 40 degrees. And if we know that angle 3 and 2 are complementary, then angle 3 also has to be 40 degrees. And we can see how now angles 1 and 3 are congruent. And that, again, would happen no matter what angle measure I would have for angle 2. So that's the congruent complements theorem. The next theorem is called, in your book, they just call it Theorem 1-4. Some books call it the congruent right angles theorem. So if you ever hear me talk about the congruent right angles theorem, I'm talking about this. And all it says is that all right angles are congruent, which makes sense, right? Because if I tell you these two angles are right angles, you'd be like, oh, that means this one's 90 degrees and this one's 90 degrees. And if you know what congruent angles are, you know that that means they have the same measure. And you're like, hey, look, these both have 90-degree angle measures. So that would mean that they're congruent to each other. And so all right angles are congruent. The next one doesn't really have a fancy name, at least the one that I know of. It says that if two angles are congruent and they're supplementary, then each one is a right angle. So in other words, if I showed you these two angles and I said, hey, these have the same measure, they're congruent. Oh, and by the way, they also add up to 180, they're supplementary. Well, then you know the only way that can happen, for them to both be the same and add up to 180, is if it's a 90 plus a 90 situation, meaning that they would both be right angles. That's Theorem 1-5. And lastly, in Theorem 1-6, we have something called the linear pairs theorem. Now, first we need to talk about what linear pairs are. So let me just kind of define a linear pair off to the side over here. A linear pair would be two adjacent angles. Adjacent angles mean they have the same vertex and they share a side. Two adjacent angles. I forgot to write the word angles. Get rid of that. Two adjacent angles whose non-common sides, so the sides that they don't share, whose non-common sides, so that would be talking about, we have these two adjacent angles, the 145-degree angle here and the 35-degree angle here. They share, I'll do it in yellow, they share this side. That's why they're adjacent, because they share a side. The non-common sides would be this side for the 35-degree angle, right? It's only a part of the 35-degree angle. And then this side for the 145-degree angle. That side's only a part of the 145. So those non-common sides form a line. And that makes them a linear pair. You can see the word line right there in the definition. So these linear pairs, it says here in the theorem that they will always be supplementary. Their sums will always add up to 180. So in this picture here, we can see, oh, angles 1 and 2, they're a linear pair. They are adjacent, they share a side, and then the non-common sides make this line right here. So we would know that those would add up to 180. And that's called the linear pairs theorem.